Hello, everybody. This is Vikram Anbargan. I'm the head of product for Amazon Lex. I'm excited to be here to present Amazon Lex to all of you. So today we'll be talking about why we built Amazon Lex, what is Amazon Lex, and how you can get started with Amazon Lex, and we can have Q&A at the end of it. So let's dive right in. So let's talk about the advent of conversational interaction, right? So many years ago, humans had to adapt to how machines understood instructions. So we had to use things like punch cards and memory registers. And then the second generation was where there was a compromise, where machines understood things like point and click and touch and sliders. And then right now, we're in the third generation of conversational interfaces where the machines completely understand how humans interact, and that is through conversations. What are the benefits of conversational access? They're natural, right? Having a conversation is one of the most natural things that human beings learn. They're on demand because you're talking to a bot, so it's available whenever you want to talk to it. They're accessible, so even folks that cannot type or have poor vision can just talk to a bot and get answers. And they're efficient because having a conversation is the fastest way of getting your point across. What are the developer challenges today when they're trying to build a conversational interface, right? So there's multiple different aspects like security, speech recognition, language understanding, the business logic, how do I scale these systems, how do I make sure they're always available, how do I take care of authentication, how do I deploy it to my mobile device. And there are solutions that do different pieces, and they need to put all of these together and build a solution for their conversational needs. And that's why we built Lex. Amazon Lex is a new service for building conversational interfaces using voice and text. And we provide an end-to-end platform for you to build your conversational interfaces. What are the features? We start with text and speech language understanding and powered by the same technology as Alexa. So what we did was most of you may be familiar with the Echo device and the Alexa digital assistant. And we took the brains behind Alexa, which is the speech recognition and natural language understanding, and exposed that as an AWS service through Amazon Lex. So you get the same high quality and of technology, as well as you benefit from all the data and the training that goes on with these models. You can deploy your chatbots to any of the chat services. So right now we have Facebook, and very soon we're going to be adding Slack and Twilio. And that's why we have a poll out to figure out what else we should add going forward. It's designed for builders. So we have an easy-to-use interface using which you can configure your bots. And also, it's fully managed and scales automatically, so you don't have to worry about provisioning enough hardware and not worry about what if this bot really becomes popular and I suddenly see a large amount of usage. We also have features like versioning and Alias Support, because we know that if an enterprise is using Lex, they'll probably have a number of different developers working on it concurrently, and we don't want folks changing each other's code and interfering in the development process. That's why we have versioning, so that every person knows the version of the intents or slots they're working with, and that never changes. We also have enterprise SaaS connectors. So we have tight integration with Lambda. So through Lambda, you're able to access enterprise SaaS connectors and connect to backend systems. And this way you can build bots that are able to answer enterprise questions. So let's talk about each of these in depth. So like I was saying, speech recognition and natural language understanding are the two technologies that we use, and they're the same ones that is being used with Alexa. Speech recognition takes an audio file and converts that into text. And one thing that we do at Lex is we use the model that you build to inform the speech recognition technology. So for example, if you built a model and you're given some sample utterances, we provide those utterances to the speech recognition software so that it knows that it is likely that what the customer is saying is among one of these sample utterances. So the chances that it converts the audio into the exact text is increased. Deployment to chat services. So with one click and by just specifying a few details on the Amazon Lex Console, you're able to quickly deploy your bot to Facebook Messenger, and very soon you'll be able to do that with Slack and Twilio as well. You can also deploy a bot to mobile devices. We have tightly integrated with the mobile hub. So if you go on the mobile hub, you will see a card to build conversational bots. All you need to do is click on it, and you will be able to see all the bots that you've already built in Amazon Lex. You pick the bot that you want to connect to, and you can download the client. We also have support for cards, rich formatting, so you're able to configure your card with the different buttons and the image, and we will take care of rendering your card on Facebook Messenger or Slack and generate the appropriate tags. So for example, on Slack, if there's no support for image, then we'll only display the buttons, and so on. Today, the situation is such that every chat platform have their own markup. So if you as a developer needed to deploy to all these different platforms, you would need to write markups specifically for each of these. What we do here is provide you one unified way of designing your experience, and then not worry about the markup for each of these specific platforms. This is a quick screenshot of the Lex Console, and this is in preview. We'll be adding many more features here and making it better and better and more easy to use. So you're able to configure your bot by providing some sample utterances, some slots. I'll go deep into what each of these components are a little later in this presentation. And you can also test your bot on the same console and make sure it's working before you deploy your bot. Versioning and alias support. So we have versioning support at the intent level, at the slot level, and at the bot level. So just to explain what these are, bots are like applications, and they're a collection of intents. And intents are goals that your customers want to achieve. For example, ordering a pizza, ordering a ticket, and checking status, and so on. And slots are the data that you need in order to fulfill the intent. For example, the names of all US cities, right? That would be a slot. A date is a slot, and so on. And once you have versioning, you also need alias support, because what happens when you're doing iterative development is you will keep releasing new versions. And every time you release a new version, you don't want to go change all your clients. Therefore, you set up an alias, something like prod, and point all your clients to the prod alias. And as you release new versions, you just switch out the version that the alias is pointing to. And you can also use this to have separate environments for dev staging and production, where when you're testing a certain version, you can provide a different alias to it and have clients that are talking to that specific alias. So saying we have tight integration with AWS Mobile Hub. So you not only get the SDK and sample client from Mobile Hub, but you also have the Cognito piece embedded there, because when you have a client on a mobile phone, you need to be able to authenticate them and make sure that it's coming from a valid source before you start answering queries. So there is deep integration with Amazon Cognito, and you can set up your user pools and do authentication from your mobile clients. And this, on the right side, you see a quick screen grab of how the console looks like and the card that says conversational bots. And once you click on it, you're able to go in and quickly configure your mobile client. Enterprise SaaS connectors. So there's different ways you can hook up your enterprise SaaS connectors. So this is one configuration where you have the mobile app and you have your bot on the mobile phone, and your salespeople can say, hey, what are my top 5 customers that I need to call today, right? And that comes to Lex. Lex understands the intent and then hands over to Lambda, which is able to connect to your backend enterprise systems like Salesforce, Zendesk, Microsoft Dynamics, Marketo, HubSpot, and QuickBooks, and is able to fetch that data and then pass that data back to your bot on your mobile application. And for those enterprise systems for which we do not have pre-built connectors, or if they're on your VPC, you can also use Lambda to connect to them. This is a different configuration where the mobile app is sitting at the center of the architecture. So you are able to talk to, send the audio that you receive or the text that you receive from the user to Lex to understand the intent. And once the intent is understood, the mobile app is able to connect to Lambda and through Lambda to all these enterprise backends and fetch that data directly. Here are some of the use cases for Lex. So the first one is informational bots. So these are examples would be where you build a bot to get news updates or weather information or game scores. You can say, hey, what was the score for the Seahawks game, or what was the score for the Lions game, and so on. And then you have application bots where they're more transactional, where you're actually booking a ticket or ordering a food, or you're managing your bank account, and so on. You have enterprise productivity bots where, like we were seeing just a few slides ago, you could check your sales numbers, your marketing performance, your inventory status, who you need to call. And you can even have enterprise productivity bots for things like help, right? So how do I reset my password? Or how do I get a new device, and so on. IoT bots, where you can actually control IoT devices using voice. So NASA built a really cool proof of concept where they had Rovi, which is a replica of the Mars rover, and they were able to control it using voice, saying Rovi, go forward, Rovi, move backwards. And they're also able to ask it questions saying, Rovi, what is the diameter of Mars? Rovi, is there water on Mars? So you can build IoT devices that are able to communicate with your users using Lex. So what are the benefits of Lex? It's easy to use. You can quickly configure your bot and then deploy it onto whichever platform you need. It's high quality text and speech language understanding because we use the same technology that is powering Alexa. You seamlessly deploy and scale, so you never have to worry about scaling your application because it's a fully managed service, and we take care of provisioning enough redundant servers so that we are able to absorb any spike in usage across all the bots that are deployed on Lex. Built-in integration with the AWS platform, so you can easily hook into other AWS services like Cognito and Lambda for your business logic, and other systems like DynamoDB to maybe maintain your state. It's cost effective. it's an AWS service, so we make sure that our users are able to access high-quality technology at the lowest price. And we also have a generous free tier, which we'll talk about in a few slides from now. This is the structure of a bot. So like we briefly spoke about earlier, a bot is a collection of intents, and intent performs an action in response to a natural language user input. And the example of an intent would be to book a ticket, check your status, and so on. Utterances are what your users speak. So things like, I'd like to book a hotel, or I would like to book some tickets, please, and so on would be your utterances. Slots are the data that you need. So the name of the city, of travel, and so on would be the different slots. And fulfillment mechanism is how you actually fulfill the intent of the user. For example, once you figured out that they want to book tickets and the day they want to travel and the city they want to travel, then you actually need to go and place the order for those tickets in the airline system's backend, right? So some code has to run to fulfill that business logic, and that's what we call fulfillment. So here's some samples for utterances. I'd like to book a hotel, make hotel reservations. Can you help me book my hotel? I want to book a hotel in New York City. So various ways in which your customers will interact with the bot. Slots, so the examples here are destination, check-in date, and check-out date. So we have two concepts here, slot and slot type. So the slot would be, for example, if in programming, it would be the name of the variable inside that particular function. So destination, check-in, check-out would be the names of the slots. And slot type is the data type, for example, int, float, and so on. Similar, we have city, date, and so on. And you are able to share your own custom slot types. And we also provide written slot types for commonly used slots like city. So all US cities, we don't need every developer to go create their own list of cities. So we provide a list of cities. And date again, right? So date is a very commonly used slot, and there's multiple formats in which folks can provide. Therefore, we provide a slot type that is able to accommodate all the different formats for dates. Slot elicitation. So what we mean by slot elicitation is, I'd like to book a ticket. You, or not you, the Amazon Lex runtime figures out that these three different slots in order to fulfill this intent, and it to elicit that data from the customer. So it uses prompts, and the prompts are, sure, what city do you want to book from? What date do you check in? So those would be the different prompts. And then it has a conversation with the user and the data, and then once it's ready, you then move on to fulfillment. Lex provides built-in slot elicitation. We also have support for overfilling. For example, if someone says, I'd like to book a hotel in New York, right? So the Lex runtime figures out that you don't ask them for which city they want to book in because they already provided that data. So it moves to the next question and says, what date do you check in? The fulfillment, we provide two ways in which you can fulfill. One is you can hand off the intent of the user as well as the slots that have been collected to the function, which is able to go book your ticket or order food. And sometimes you may already have a mobile app, right? You have a mobile app and you just want to add a conversational interface to it. So in that case, we also are able to return back all the data to the client so that the mobile app can just function as it all does. This is kind of the flow of how a request comes in and what we. So let's say your user said, book a hotel NYC. That's the audio file that comes in. Speech recognition takes that audio and splits that into text. Once you have the text, you to the natural language understanding system, which is able to understand that the intent is to book a hotel. Hotel booking is the intent. And they've already provided one of the slots, which is the city slot, and the value for that is New York City. And the natural system uses the bot data that you provided on the console when you configured your bot in order to make these determinations. And then it understands that I need to now ask them for the check-in date. Right? So it will say, what day do you want to check in? Once you have the data, it will say, what date do you want to check out? Once it has all the data, we have a concept called a confirmation prompt, where it'll can I go ahead with the booking for New York City on the 30th of November, checking out on the 2nd of December. It will be $25 a day. And then you can say yes. And once the transfer goes to Lambda, or if you choose, it could go back to the client. Once Lambda executes and the control comes to the Lex runtime, you can also provide a message back saying hotel is now booked for the 30th of November. And that text is then sent to Poly, which is our system. It's converted into into audio, and then to the user. That's kind of the flow for requests that comes into Amazon Lex. Let's talk a little bit about the save, build, and publish. So we have the save functionality. Developers like to keep saving as they're working, that they don't lose their work. But when you save, we are not newer versions. We just save the state as is. There's the build functionality, where when you click on build, we take all the data that you saved so far and then build the model on the Alexa backend. So that's where we build your intent model with all the data that you provided, with all the sample addresses, with all the slots, with all the prompts, and so on. Then you can test once you've built, because the machine has already been built on the backend. Now you can start testing from your console, chat with the bot, and it will start responding to you. And once you can then click on publish, and publish creates a new version of the bot. With build, I should also mention that new version of your intent and slots are created, but your bot is still not, a new version of your bot is still not released when you build. When you publish, a new version of your bot created. And then you point an alias to that version and start using that version of your bot. Monitoring is a really important, because once you've deployed your bot, you want to see how well it's doing. So right now we provide missed utterance count that tells you of the 100 requests that came in, how many of the requests to be mapped successfully to an intent, latency, how long did it take us to respond, traffic by channel, how much of your requests are coming from Facebook or and so on. And we're going to keep improving here, and we'd like some feedback from our customers, more and more monitoring to Lex, so that it's useful to you to keep making your bots better over time. Here are some customer testimonials. So one is building a POC with they're already on Alexa, and now they want to also put their bot on Facebook and other platforms. So trying out Lex. HubSpot building Growth Bot on Lex, which is an all-in-one chatbot which helps marketers and salespeople be more productive. Here's the pricing for Amazon. So for 1,000 speech requests, we charge $4, and for 1,000 text requests, we charge 75 cents. So during your first year, we have a free tier of up to 10,000 text requests per month and 5,000 speech requests per month. Here's kind of a simple representation of the architecture for Lex. So I'm going to start from the left. So during build time, you have the console as well as the API using which you can specify intent, slots, prompts, and utterances and build your model on Amazon Lex. Once your model is built, you can deploy it to multiple platforms like mobile, web, and different chat services. And we provide SDKs as well. And then we have runtime APIs. You can provide either speech input or text input, receive back either text or speech, and then communicate with your bots from your clients. We provide deep integration with services like Cognito, CloudTrail, and CloudWatch for authentication as well as logging that provides more visibility to how your bot is performing. We, of course, speech recognition and natural language technology provided by in order to understand what the customer is saying and figure out what the intent of that text is. And then we integrate Lambda in order to fulfill the action the customer wants to perform. That brings us to the end of this presentation, and now we'll be having the question, how do I get started? So to aws.amazon.com/lex, and you can quickly register for getting your account white, and we should be able to whitelist you over the next few weeks. And then once that's done, you'll be able to see Lex in the AWS console. You can start using Lex. Some of the features which on the UI are, we have sample bots that are already available. So for folks that are new to conversational interfaces, you don't have to struggle trying to build your first bot. You just, with one click, create your bot and immediately start testing it and playing around with it, getting a feel for how the bot works. So it's pretty easy to use, and we hope you guys build a lot of really exciting and creative bots on this platform.